name followed by the pound sign.
None of them are executed. For example, imagine a scenario where your database transaction contains 4 SQL queries, and while executing the transaction, the third SQL statement fails. In this case, the first 2 SQL statements that are part of the transaction would be rolled back. That is, none of the changes made by the first 2 SQL statements would be committed to the database. This way, your database would always remain consistent whether transaction succeeds or fails. The commit and database and rollback removes temporary changes logged in transaction log by database transaction. To ensure the integrity of transactions, database systems must follow ACID properties. ACID is the acronym for atomicity, consistency, isolation, and durability. Now let's look into what each of these properties mean. Atomic means all or nothing. That is what transactions are all about. Consistent means that database has enforced all integrity and data constraints on the table so that transaction must leave the database in consistent state even if it succeeds or fails. Isolation means that the users or database sessions don't affect each other. When 2 sessions goes into transaction, they don't see the results of each other until data has.
Your line has been muted.
Durable means that
Your line has been unmuted.
it will be permanently present in the database. Now, let's go through the classic example of database transaction, an ATM machine which we use to withdraw money in our everyday life. If you break withdrawal operation into individual steps, you will find that it consists of the below steps. Step 1, verify account details or PIN number. Step 2, accept withdrawal request. Step 3, check balance, and if a sufficient balance is available. Step 4, update balance, and step 5, dispense money. Suppose your account balance is $1,000 and you want to make a withdrawal request of $900. At 4th step, your balance will be updated to $100. And suddenly, the ATM machine stops working due to some unexpected technical issue. Once the issue is resolved, you will try again to withdraw money. But you would be surprised if your balance is shown as $100 instead of the original $1,000. Showing balance as $100 is not acceptable by any person in the world. So we need transaction in such scenarios. If SQL statement would have been executed inside transaction at the database, the balance would be either $100 until money has been dispensed or $1,000 if money has not been dispensed. All the above statements form a part of transaction. That is, either all of them are executed or none of them are. Now, let us move to transactions within PowerCenter. A transaction within PowerCenter, unlike database transaction, is a set of rows bound by commit or rollback rows. These set of rows form the transaction within PowerCenter. The row at which commit or rollback is generated forms the transaction boundary. PowerCenter has a lot of options that help you to define transactions that the integration service uses when it processes transformations. These options help users to decide when to commit or roll back data at a target database. We will be covering the details of the same in the coming slides. Also, we need to know that in PowerCenter, all the incoming rows from the source need not be bound by transaction boundaries. These rows, which are not bound by transaction boundaries, form an open transaction. You can choose to commit at end of file or to roll back open transactions when you configure the session. For example, imagine a situation where the source table has 6 rows and the mapping has been defined in such a way that the first 3 rows form part of one transaction and the next 2 rows form part of another transaction. The last one row is not bound by any commit or rollback row and hence is a part of open transaction. The set of rows that are present in the first and the second transaction, that is basically the first 3 rows and the next 2 rows, would be committed to the target database separately. You have an option within PowerCenter to commit or roll back the last row. Now, let us see an example of transaction within PowerCenter. Imagine that you have a mapping that needs to process monthly data. The data that needs to be processed for each month is present in a separate flat file source. In this example, there are separate flat file sources for the month of January, February and March. I am sorry, there is some disturbance. Hello, there is some disturbance in the line. Can you please mute all your audio, please? In this example, there are separate flat file sources for the month of January, February and March. The PowerCenter mapping reads the data from the source files using indirect file mechanism. Imagine that you have a TCP transmission in the mapping that controls the transaction boundaries for the incoming rows of data with respect to each month. In addition, imagine that you have an aggregator transmission at the mapping level. You can configure aggregator transmission in such a way that it will not wait for all source rows of data. It can process just the rows of data that are part of month at a time and pass the information to the next transmission. These set of rows that belong to one month form a transaction within PowerCenter. As you can see that data for the month of Jan would be committed to the database and then Feb and then March. Thus, PowerCenter gives you the ability to control transactions to decide the set of rows you want to process as a part of your transaction and when to commit or roll them back. Now, the basic question everybody would have in their mind is, why do we need transaction control in PowerCenter even though it's a database operation? Why can't we leverage the transaction control to database, and why should we implement it within PowerCenter? Let us look at the example of a simple session reading data from database or flat file and writing data to the target database. Imagine a scenario where there is no transaction control within PowerCenter. When the integration service initializes a session, it allocates blocks of memory to hold source and target data. These are called the DTM buffer blocks. These DTM buffer blocks would be available for the reader, transmission, and the writer thread. Since we are dealing only with commits, we would be commenting only about the DTM buffer blocks of the writer thread. Once the data has been read from the source database, the data would be held in buffer blocks. While running the mapping, operations would be performed.
Your call on hold. ನಿಮ್ಮೊಂದಿಗೆ ಮಾತನಾಡುತ್ತಿರುವ ವ್ಯಕ್ತಿಯು ನಿಮ್ಮ ಕರೆಯನ್ನು ಫೋನ್ನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. जिस व्यक्ति से आप बात कर रहे हैं, उसने अभी आपकी कॉल को होल्ड पर रखा है.
Okay, I think somebody has put this call on hold.
Just give a minute.
Presentation mode is now enabled.
All users. Okay.
So I'm going to continue the presentation. So coming back to this slide. They can't hear my voice.
Now start.
I'm just going to run through the same slide again. This is an example of a simple session reading data from the database and writing data to a target database. When the integration service initializes a session, it allocates blocks of memory to hold source and target data. These are called the DTM buffer blocks. These DTM buffer blocks would be available to the reader, transformation, and writer thread. Since we are dealing only with commit, we would be commenting only about the DTM buffer blocks for the writer thread. Once the data has been read from the source database, the data would be held in buffer blocks. While running the session, operations would be performed on the data held in the DTM buffer blocks. PowerCenter would be waiting to push the data to the target database. Until PowerCenter explicitly commit data to the database, the session process would be holding the data in memory blocks. Imagine a scenario when the incoming data is huge. If PowerCenter doesn't explicitly commit data, the server would eventually run out of DTM buffer blocks and session would fail. In short, until the data is committed in the database, the PowerCenter server holds all the uncommitted data in the DTM buffer blocks, and we might run out of DTM buffer blocks in case if you don't control when to commit data to the target. Also, another important advantage is for the Informatica recovery process. Imagine a scenario where we have read more than 1 million rows from the source and are yet to commit the same at the target database. If the session fails unexpectedly in between, we have to read all the rows again and wait for the entire set of rows to be processed before committing data to the target. If we have a mechanism to control commits from PowerCenter while recovering a session, we need not process already committed data at the target database. Remember the scenario where we mentioned about reading data for the month of Jan, Feb, and March from the source flat files? During that session, imagine that the session has read January data and committed the same to the target. And before committing the data for the Feb month, the session failed due to an unexpected error. If session has been enabled for recovery from last checkpoint, during recovery run, we can skip reading and processing January data as the data from Jan is already committed in the target database. Let us look at another case where we leave the entire transaction control operation to the database. PowerCenter would not be able to report in its session log statistics showing that these many rows have been committed to the target, as this operation has been entirely leveraged to the database. PowerCenter would not have control on when the database commits data to the target, and hence the responsibility would fall on database administrator to keep a check on whether the target data from PowerCenter has been committed or not. But it all boils down to one particular question. How do we control transactions in PowerCenter? We control transactions within PowerCenter by using transaction control points at the mapping level and using various session level properties. Transaction control points are transformations like TCT, some active transformations like aggregator, joiner, etc. at the mapping level, which can either generate transaction boundaries or can drop incoming transaction boundaries. Also, you can control transactions by using session properties like commit interval type, commit at end of file, and rollback at end of file. So coming to the main and the important slide of this presentation, what is a commit point? A commit point is the point at which we commit data to the target table. Commit point is the factor of commit interval, buffer block size, and commit interval type. We will go in details about each and every one of the factors so that we can understand about commit points better. Commit interval is basically the interval at which integration service commits data to the target during a session run. This is a configurable property and its value can be set at the session level. By default, the value of commit interval is 10,000 rows. In other words, commit interval is the number of rows that you want to use as a basis for your commit point. Buffer block size specifies the amount of memory used to move a block of data from source to the target. You can configure the buffer block size on the Config Object tab in the Session Properties. Commit interval type is the type of rows that you want to use as a basis for your commit point. There are basically three types of commit interval: source-based commit interval, target-based commit interval, and user-defined commit interval. This slide shows where you can set commit interval at the session properties level. Similarly, commit type is also a session properties which can take the values source, target, and user defined. So let us now go ahead and discuss about source-based commit. When you run a source-based commit session, integration service generates commits based on the number of source rows. The commit is generated at all source qualifiers and transformations that do not propagate transaction boundaries. These transformations are called active sources. This includes the following active sources: source qualifier, application source qualifier, aggregator, joiner, rank, sorter, etc. These active sources form the commit source for each pipeline in the mapping. That is, when you run the session, the integration service generates a commit row from these active sources at every source-based commit interval. The number of rows committed to the target will be same as the commit interval. The number of rows held in the writer buffers does not affect commit point for the source-based commit session. So let us see the example of a sample pass-through mapping with session configured with source-based commit of 1000 rows. Imagine the source has 3,300 rows of data. While running the session, data would be read from the source database. Since the session has been configured with source-based commit interval of 1000 rows, for every 1000 rows, a commit would be generated. The last 300 rows are not bound by any commit or rollback row and hence forms a part of open transaction. You can choose to commit the last 300 rows or roll them back. There can be cases where the number of rows are less or more than the commit interval. For example, you have a source-based commit session with commit interval configured to be 1000. When the 1000th row passes through an active source, it is treated as a commit row. But further along the pipeline, imagine 300 rows are dropped due to transformation logic. The integration service issues a commit to the target when the 700 remaining rows reaches it. So the next question which arises here is, when a mapping has two or more active sources, which one takes effect? Let us look at the mapping with multiple commit sources. The above mapping reads data from Oracle database and branches from the source qualified transformation to two targets. One branch contains a sorter transformation and is associated with the target sorter_test, and the other contains expression transformation associated with the target target_exp. While running a session with source-based commit, the integration service identifies source qualified transformation as the commit source for the target target_exp and sorter as the commit source for the target sorter_test. It performs a source-based commit for both the targets but uses a different commit source for each. In short, commits are generated by the active source that is closest to the target definition. So now let's see how a source-based commit works while running a session. I'm just going ahead and showing you the details of a simple pass-through mapping containing a source and a target. At the corresponding source level, I have configured the commit type as source and commit interval as 1000. Let me go ahead and run this corresponding session. Since the session has been configured with a source-based commit interval of 1000, for every 1000 rows, a commit should be generated. So let's go down the session log and see when a source-based commit is being generated. So here you can see for the first 1000 row a commit is generated, and for the next 1000 row a second commit is being generated, and all the data which is being present in the source are committed in the target in an interval of 1000. Now let me go ahead and show you another session, another mapping which contains multiple active sources. This is an example of a mapping having source qualifier as well as an aggregator transformation. Both of these are active sources. Since aggregator transformation is closer to the target, aggregator transformation would act as an active source for this corresponding mapping. Let me go to the corresponding workflow and see the configuration properties. I have set the commit type as source and commit interval as 1000. Let me go ahead and run this session. From the session log, I can see that the commits have been generated for every 1000 rows, and both of the targets, since they are present in the same target load order group as well as same target connection group, are being committed simultaneously. So 1000 rows are being committed in multiples till all the data from the source reaches the target. I hope all of you have now understood about source-based commit. Let me go and explain about target-based commit now. During a target-based commit session, the integration service commit rows based on the number of target rows. The commit point depends on the following factors: commit interval, buffer block size, and writer-wait timeout. When you run a target-based commit session, the session process may issue a commit before or after the configured commit interval. We have already looked into what is the commit interval and what is the buffer block size. Let us now see what is writer-wait timeout. Writer-wait timeout is the amount of time the writer waits before it issues a commit. If the writer thread is idle for time specified above the writer-wait timeout, it writes and commits data to the target. You can configure writer-wait timeout in the integration service level under configuration properties. You can also set the value of writer-wait timeout as a custom property at the session level as shown in the diagram. By default, the value of writer-wait timeout is 60 seconds. Now let us see in detail about how a session process determines when to commit a session during a target-based commit. Let us look at the example of a simple session reading data from database or flat file and writing data to the target database. When the integration service initializes a session, it allocates blocks of memory to hold source and target data. These are called DTM buffer blocks. Imagine a scenario where the session has been configured with a target-based commit of 1000 rows. Once the data has been read from the source database, data would be held in buffer blocks. While running the mapping, operations would be performed on the data held in DTM buffer block. When the integration service reaches a commit interval, that is 1000 rows in this case, it continues to fill the writer buffer block. When the writer buffer block fills, the session process issues a commit in the case of a target-based commit. Here it is the DTM buffer block which plays an important role on deciding how many number of rows needs to be committed to the target. In this special case, the number of rows committed would be greater than that specified in the commit interval property at the session configuration. Now, imagine the same session but another scenario. The session has been configured with a target-based commit of 1000 rows. When the integration service initializes a session, it allocates DTM buffer blocks. While running the session, imagine that the writer buffer fills before the commit interval. The integration service writes data to the target, but it waits to issue the commit. The session process continues to fill the buffer and issues the commit when it reaches the commit interval and fills another writer buffer. Here, the amount of rows committed to the target can be more than or equal to that of the commit interval. Now let us see a scenario where the writer-wait timeout plays an important role. It's the same session which has been configured with target-based commit of 1000 rows. When the integration service initializes a session, it allocates DTM buffer blocks. While running the session, imagine that the writer buffer fills before the commit interval. The integration service writes data to the target but waits to issue the commit. The session process continues to fill the buffer and issues a commit if the writer is idle for the amount of time specified by the integration service writer-wait timeout option. Here the amount of rows written to the target can be more or less than that specified in the commit interval. Now let us see how a target-based commit works while running the session. Here is an example of a simple pass-through mapping having a source and a target. At the session level, I have configured the commit type as target and commit interval as 1000. The DTM buffer block size has been configured to 1 MB. Let's go ahead and run the session and see how it works and what is the number of rows which are committed to the target. Let me go ahead and open the session log. In the session log, I can see that the number of rows committed by a single commit point is 11,648. And in multiples of 11,648, data is being committed to the target till all rows are committed. Now let us see the impact of increasing the corresponding buffer block size. I am going ahead and increasing the default buffer block size to 10 MB. Let me save the session and run the session. Since 10 MB is a very huge value, my hunch is that all the rows from the source would be written to the target in a single commit interval. If you see here, 39,999 rows are being read from the source, and all of the rows are being executed or committed to the target in a single commit point. I hope now you are all clear regarding how a target-based commit works. Now let us move to user-defined commit session. During a user-defined commit session, integration service commits and rollbacks transactions based on a row or set of rows that passes through transaction control transformation. The integration service evaluates the transaction control expression for each row that enters the transformation. The return value of transaction control expression defines commit or rollback point. You can choose to commit at end of file or roll back that open transaction. The entire responsibility to define the rows that are present in the transaction would be leveraged to user. Let us now see and run a sample user-defined commit mapping. Here is an example of a source table containing two fields, ID_source and name_source. As you can see here, the field ID_src has constituted numbers from 1 to 37. Let me go ahead and open the corresponding mapping using user-defined commit. As you can see here, is the same mapping reading data from the table shown in the presentation, and we have a transaction control transformation. At the transaction control transformation, we have the condition as if ID_source is divisible by 5, then we go ahead and write the current row to the target, commit the transaction. So all rows which are bound or till the row which is divisible by 5. ID_source which is having a value which is divisible by 5 will be committed to the database. And we will begin a new transaction starting from the next row. So let me go ahead and open the corresponding session. At the session level, you can see the commit type as user defined. If you see here, I have selected the property commit on end of file. I have not selected the property commit on end of file. If I go ahead and run this session, I can be very sure that rows with ID_source 1 to 5 would be committed in the first commit point. Rows from values 6 to 10 would be committed in the second commit point. So you can see that the corresponding commit would be happening at the target database in an interval of 5 rows. This row with ID source 36 and 37 does not fall under any, it falls under open transaction, and since I have selected the property, since I have not selected the property to commit those rows will not be committed to the target database. So I have just run that session. We can see here that the session read 37 rows and rows are being committed to the target in an interval of 5. If you scroll down further, you can see that there is a command which does a rollback for the last 2 rows which is being read from the source. Now let us go ahead and run the same session after selecting the property commit or end of file. This would make sure that all the 37 rows are being committed to the target. So if you can see here in the session log, 37 rows are read from the source and rows are committed in an interval of 5, and you can see all 37 rows are being committed to the target database. Now let us go ahead and discuss regarding transformation scope. You can configure how the integration service applies transformation logic to incoming data with transformation scope property. This is one of the properties that controls transactions within Informatica. When the integration service processes a transformation, it either drops transaction boundary or preserves transaction boundary, depending on the transformation scope and mapping configuration. There are 3 different transformation scopes that you can set at each transformation within the mapping. They are row, transaction, and all input. When you select row as a transformation scope, the integration service applies transformation logic to one row of data at a time. For example, in the case of a source qualified transformation or expression transformation, the transformation scope would be by default set to row. When you select transaction as a transformation scope, the integration service applies transformation logic to all rows in a transaction. You have to choose transaction as a transformation scope when a row of data depends on all rows in the same transaction but does not depend on row in some other transaction. Imagine a scenario where you have a mapping with source-based commit and have aggregator as the active source. If you select transformation scope for this aggregator as transaction, the integration service preserves incoming transaction boundaries, implying that the aggregator has no effect at all as an active source. When you select all input as the transformation scope, the integration service applies transformation logic to all incoming data. Imagine a scenario where you have a mapping with source-based commit and have aggregator as the active source. In this case, if you select the transformation scope of aggregator as all input, the integration service drops incoming transaction boundary, implying that aggregator would act as an active source. Now let's see how transformation scope can be set for various transformations at the mapping level and the impact for the same. Here is an example of a sample mapping having TCP transformation and a sorter transformation. At the sorter transformation, I have selected the transformation scope as all input. This implies that the TCP transformation has no effect at all. If I go to the properties of the TCP transformation, let me go ahead and refresh the mapping. Okay. I can see that the commit type can be set to source, target, and user defined irrespective of the condition that TCP transformation is present at the mapping level. On the other hand, if I go to the sorted transformation in the mapping and select the transformation scope as transaction, it implies that the TCP transformation would be respected. So if I go to the session, refresh the mapping, I can see that the commit type has been set to user defined. So by this I hope you have a better understanding about what is transformation scope and how can it be used within PowerCenter. With this we have come to the end of presentation. We are opening the lines for question and answer session. If anyone has any questions, this is the time. Do anybody have any questions over the phone?
Presentation mode is now disabled.
Do anybody have any questions now?
Yeah, Ani, you can hear us?
Yeah, please go ahead.
Yeah, when you are using this commit interval,
Okay.
and there is a commit for every 1,000 records, there will be a commit and in the Informatica level.
Is it a source-based commit or a target? Is it a source-based commit or a target-based commit?
Source-based.
Okay.
Got a failure after 2,000 records, or 2,500 records after some 2 commits happened.
Okay.
We restart. So will it take from the record or from the 3rd commit point, or how it will be, the restartability will be working in this?
Okay. So if you restart the whole session, Informatica doesn't have any prior knowledge of the two set of commits that has happened to the target. Okay. But on the other hand, if you had selected recovery from last checkpoint option at the session level and you run and you recover the session, Informatica would commit the data starting from 2,000 rows only. So restart will not take care of the data being committed at the target level. But if you had enabled the option of recovery and recovery from last checkpoint, we can be very sure that the rows from 2000 and onwards would be committed only.
That's where we should delete the data in the database, the table, and then we can restart.
Yes. We can't use Informatica to understand that basically 2,000 rows are being written to the target, has already been written to the target. So you'll have to use your database administrator probably to delete those rows and then run the session again.
Vani, I have one question. This is Malik here.
Sure.
Hello.
Please go ahead, please.
Yeah. Suppose I have set a source commit for 1,000 rows, and I have in my session it has only 1,300 rows. So it has committed first 1,000 rows, and for next 300 rows, how much time it will wait to commit them?
No. So at the commit, if it is a source-based commit, imagine that 300 rows will fall as a part of open transaction, right? So once the 300 rows reaches the target, it would generate a commit if you had selected the property commit at end of file. So for source-based commit session, if you had not selected that property, that 300 rows will not be committed. So there is no time limit or anything that has been set at the Informatica level for a source-based commit session.
Can you repeat that last statement? We have to select commit at the end of file for the 300 rows to get committed.
You have to select commit at end of file. So if you are able to see my session right now, okay.
Yep.
Can you see my session? You have this property at properties tab of the session. commit on end of file. So you have to select this property so that the last 300 rows which forms the part of open transaction are committed to the target database.
So suppose if it is even the same stays in contact for database, if it is from a table or something?
No, I didn't understand that question. So imagine a case where you have 13,000, that's what you were mentioning, right? 13,000 rows, and you were setting 10,000 as the commit interval.
Yep.
Yeah, so that 3,000 rows which are not part of the transaction or which falls under open transaction would be committed if this property has been selected.
Yeah, so commit on end of file is it only for if source is file or source is any database or anything?
It is for database also.
Okay. So it's like number of
it's not
rows.
like it's number of rows that it's for open transaction basically.
And in case of target based, how that will work? Those 3,000.
No, target based this property would be selected by default. You will not be able to change this property.
No. Suppose I'm saying like I have set target based commit as 1,000, and my source has read 1,300 records, and how those 300 records will be committed?
Your target based commit depends on target rows and is not at all a property of the number of rows which is coming in. I've just opened a target based commit session, and if you see here, commit on end of file is they selected by default, and you can't change it.
Okay.
Because it doesn't depend on the number of source rows at all. It depends entirely on the buffer block size and the commit interval plus the writer wait timeout. So here the number of source rows which is coming in doesn't have any effect at all.
Okay, got it. Thank you.
Bani, this is Amit. I have a question about.
Sure, Amit. Go ahead.
Let's say I'm putting to a particular table, and simultaneously my users are accessing that table using query or reporting tool. So I don't want to have a time lag. So what is the best method to use, like source-based, target-based, or data-driven? Assuming it's like a transaction data.
Look, I will not be able to let you know what is the best use case or best business. The selecting source-based, user-based, or target-based is entirely dependent on the business use case, and I don't think it has any relation with the user accessing the database table. I'm not sure what kind of clarity do you need. What kind of more information do you need from our side?
Like,
for example, usually for. Sorry, go ahead.
Yeah, it's like when you are loading data into your target table, and your reporting layer is accessed, it's 24/7. So anytime they can run a report. So the question is like there should not be any delay that our loading is happening, is not run a report. So we can't say that to the user. So what will be the best method to use? Like it's not about the volume of data. It's about like should you use a target base or source base? So what will so which method will not have the dirty thread? Like the particular transaction is getting loaded and at the same time I will be accessing.
I am not clear regarding the question. Like you see here, we are controlling transaction using commit interval in Informatica. Okay. So we have seen scenarios where we are using source-based commit when there are real-time sessions, when there are real-time sources. Okay. So it is dependent on the business use case, and I'm not sure, what we'll be able to provide you with the best suggestion, regarding source or target or user defined. So if you want to, like for example, the example I gave, when you want to aggregate or distinguish the data depending on different months, and you want to process the data for a single month itself, you'll have to use a user defined transaction. And in case if you are using a real-time source, we always suggest to use source-based commit. For target-based commit would be the default commit interval type when you create a session.
Okay.
So We don't have any kind of recommendation saying that, you know, in this scenario use this as the commit interval type.
Okay.
Any other questions on the phone?
Hi, Vani.
Hi.
Hello. Can you give me any scenario for source-based commit?
Yeah, as I mentioned, right, when we use a real-time session, we always use, you know, we have seen customers using source-based commit. So source-based commit, we can be sure that depending on the number of source rows, a commit is getting generated. So you want to commit for every 1,000 rows which is coming from the source, you can use a source-based commit session.
Okay.
Okay.
Any other questions?
Any other questions on the phone?
Hi Vani, this is Javed. I actually missed your session, so it's a common thing I'm asking. How soon will this session be? The recording will be shared on the communities, or you'll be sharing it to the all consultants who have joined now this call.
Hi, Sidhu here. So this recording will be shared on the YouTube, and it's also, you know, the link is there. So you can just go to YouTube and search for Informatica Commit Based Interval. In next 2 or 3 days, early next week it should be on the YouTube.
Okay, and Dipesh, is there any chance that you can just forward the same link to the people who have joined today, the WebEx?
Yes, I can do that as well.
Yeah, thanks, Dipesh. Thanks, Vani. Yeah,
thank you.
Thank you.
Yeah. Any other questions? Okay, I think we don't have any other questions. Thank you so much for your time today, and thanks again.
Thank you so much. Have a good day.
Yeah, thanks, Vani. Thanks, everybody. Thank you all. Bye.
Okay.